Good day, folks. This is tutorial number 12 in the series that I'm doing for finite element in 3D experience. I recently saw a video segment by the YouTuber below, Dr. Wagner, and he was he was replicating the steps in a free software, which is called Pre-Pro Max, and trying to emulate the paper that you see right above it. I found it interesting, so I started making segments on that, and I've already done this problem, which is linear buckling of wind turbine tower, uh, already in tutorial 11, which is in this playlist of mine that you see there, and it's down here. Maybe around maybe 4th, 23rd of November. Now, the only thing is that when I did that, I actually created the three-dimensional shape, okay, which is the wind turbine tower, based on the information that was provided in that paper and the YouTube reference. But the only thing, one thing that I didn't do actually was that create this very bottom uh, section, which is 142 millimeters. That's why you can't even see it. So I didn't do this bottom one, but did everything else you by directly generating geometry. However, uh, Dr. Wagner indicates that he has already stored the tower geometry and the flange geometry, which is only just that piece up there, and save it as a step file that can be retrieved. So in this tutorial number 12, I'm going to repeat that same problem, which is tutorial 11, except that I'm not going to build a model, but import those two files or those two step files and start from that on. It's a good learning experience because things are not as straightforward as one might think. Okay. And what I'm going to do when I import that, it's going to be one basically surface, which I have to extract the pieces out of it because these sections have different thicknesses. So I will extract things and which have the same thickness, should have the same thickness, and then join them to get one piece that everything has that particular thickness, for example. And repeat that thing for all these thicknesses that you see here. And the extract icon in 3D experience is this thing that you have to go to the generative shape design and get the appropriate tab, which is surfaces, and you see that. Okay, and then the actual thing that's going to be imported, it can be meshed with the quad element once, but then when it comes to defining properties, the properties depend on what section you've got, section thickness you've got. This is coming from the YouTube reference, and it shows you the thicknesses and the diameters and things like that. But again, I don't need these things. The only thing that I need the actual thickness later on, as you will see. We are doing linear buckling analysis. Therefore, all we need is Young's modulus and Poisson ratio. And this is how you download those two step files. One of them is for the tower, which is about 14, 15 sections on top of each other. And then there's that last one, which is just the flange, which is just one section on the top. Okay. So these are the two files that you have to download. And I've already done that, so I'm not going to go to that site. I've already downloaded these things. You get there. Now, when it comes to the problem under consideration, this buckling problem, uh, the paper considers two loads. I'm only going to do the second one. In other words, This is coming out of the pre-Pro Max tutorial. This is coming directly out of paper. There is the weight of the tower and the flange, of course. There is a moment on the top, as you see applied. There is a shear force like that, okay? And then there is the torsion like so. And finally, the downward vertical force. You can think about it as the weight of that propeller and all everything on the top. Anyway, I'm going to do only this load case. Okay, so buckling with this load case only. Now, when it comes to meshing, in tutorial 11, I said that you have to make sure that the duplicate nodes are merged, because the duplicate nodes are nodes that are in vicinity of each other. In my case, in that problem was 10 millimeter merged, but we don't have to do that, because once we download the step file, then we create a single surface and we can mesh the whole thing. Okay, that's why I'm not worried about this particular pull down menu. So first of all, you take one section, everything is there, parabolic element, size 100 millimeter, and then we don't have to worry about that. And then when it comes to sections, selecting sections, you have to take the section with the appropriate thickness, okay? All right, so on. And now when if you run it, you may get the message on the default number of maximum iteration, which is 30. I believe that there's not enough iteration available. So what I did, I suggest you make this thing. I did it 200 and it worked fine. Now this is the result from the paper. The load case 2 corresponds to the two on the right hand side. This is the first load buckling factor to 1.4, and this is the second buckling factor, almost 1.56. Okay, and I'm not going to worry about this the load case 1. So we're going to compare our results with what you see over there. All right, let's go ahead and do that. Okay, here is a part file that I've started. Now I'm going to import those step files by going to this plus sign up there, import. Okay, right here, these step files have already been downloaded on my desktop. So let me go ahead. Here is the flange step file. It's so I'm going to open it. It's going to go into a new part file. You can see that it's called 1A. Okay, there's the flange. And do it again. This time it's going to be the tower. There's the tower. Say okay. And okay. And there's the tower. So notice that if you go to, for example, the tower is right there, it's in a geometric set. So what I can do is I can go ahead and copy this geometric set, copy, and go back to my main file, main part, and paste it. It's already pasted. You can see that. There we are. Right there. You see that? And then I go to 2A or 1A, which was the flange, and I can just copy this, right click, copy, copy, and I go to the main part and just say paste it. There it is. It's pasted right over there. Okay, these two files that I opened, I don't need them anymore. I just close them. This is my main file where all the calculations is going to be done, and might as well save this thing. All right. Well, first thing I'm going to do is I will apply material to this. So let me go ahead and go to tools. Here's material, create the material. And simulation domain is checked. And I'm going to call this thing November 30th. 2025. 2025. Steel. And then we say okay. And there we are. So I'm gonna apply this to my part. Let me go back there. Let's try again. There, your browser. Apply. Close that. There we are. Now it's okay. And I have to put the density there. So structure, general, density. I need this because the weight of the tower and the flange is also considered. And then we go to Abacus Multiphysics, mechanical, elasticity, elastic, 210 gigapascal, 210 gigapascal GPa, and Poisson ratio 0.3. Poisson, oops, wait a minute. 210, I don't know what I put in there. GPa, yeah, and then 0.3. 0.3, we say okay. So it's done. Now we're going to join these two. So to join these two surfaces, obviously I have to go to generative shape design. We're already there. Okay, double click on this first. Okay, we are already in generative shape design. I did not realize that. We were already there. So here's the join. And you go to geometrical set, this fellow and that fellow. And then we say, okay. All right. Now, what I like to do, by the way, you can see that this 17 mil, this very short section that was not a layer, that was not modeled in tutorial 11 is over there. I'm going to use it now. Now notice that these 8 layers, the patches, have 17 millimeter thickness. So what I'm going to do is click on the Essentials tab. I am in generative shape design. You can see that. And there is the extract icon here. There's the extract icon, and make sure you activate this group thing, otherwise you won't be able to take more than one of these. So if when you activate this, then you can take as many as you want. So this fellow and that fellow, you zoom in, and this guy and that guy, they all have 17 millimeter thickness. Let me turn it around. The other 8 patches, so we can pick the other 8 patches, that fellow and this fellow. And this guy, oops. This last one, I didn't want the edge. Remove. I wanted the face. This patch here. Right there. Okay. And the one next to it. The one next to it. Okay, very good. And notice that I've extracted these 1, 2, 3, 4, 5, 6, 7, 8 sections. Okay. And I'm going to join them. So here's join from here all the way there. You say okay, and I'm going to rename this thing properly so that I know it's the 17 millimeter one, that it will have a thickness of 17 mm. Later on, I'm going to declare the thickness of these things to be 17 millimeters when I go and to the shell machine. Okay, very good. Now let's go and repeat this thing for the next set, which is going to be 16 millimeters, I believe. Yeah, 16 millimeter, 2 patches. or 2 layers. So first of all, we're going to extract. Okay, extract this, and make sure that we get that guy activated. That fellow and that fellow. Turn it around. Probably these can be automated by writing a few lines of code, but it's not worth the time in this problem at least. So that is another 8. You can see that. You count it, it's going to be 8. Then we're going to join them. So from here all the way to down there. And then we say OK. And I'm going to call this thing, what is that? 16, right? 16 millimeter. Properties. Okay. Good. Now the next one is going to be 1, 2, 3, 4, 5 layers, 15 millimeters. So let's make sure we get this thing right. So we go here, extract. It starts here, right there. Okay. Let me get the bag. It start there. So and the other side. Say okay. And we're going to join these. Join these 20 patches. You can see from here all the way to there. We're going to join them. And I'm going to give the prefix of 15 there. Proper join. I'm going to give it prefix of 15 millimeter. 15 mm. So okay. Good. The next one is going to be 4 layers, 14 millimeters. So let's go ahead and do that. So extract. Where did we extract it up to that point? Okay, so let's get this thing out of the way. Okay, so we start here. This one, that one. 4 layers. Okay, and we're going to join them. Join from here all the way to there. And we're going to call this thing 14. Properties. 14 mm. Then it's going to be 2 layers of, I believe, 13. 2 layers of 13. So we're going to extract. There is that fellow and that fellow. These guys. Let's turn it around. All right. And we're going to join these from here to here. These are 13 millimeters. Okay. The last one is going to be also extract. All right. And then join these. I'm going to change the name, put a prefix of 50 millimeters. Very good. Let's do a quick save here. Okay. So we're pretty much done as far as the geometry is concerned. While I'm at it, I'm going to create 2 points, one on the very top, right at the center of that top circle, and one at the bottom, because later on we're going to be using the coupling in order to apply the appropriate boundary conditions. So here's the top point, and I'm going to use center of a circle, and all I have to do is to select one of these patches, one of these edges. The center of that is going to be the center of the top circle. So we can see that it's right there. And then another one down here. And another point at the center of this arc, for example, right there. You can see that it was created. Good. Be safe. And we're pretty much done here. So now we're going to go to structural, for meshing purposes, structural model creation. I click on that, and I use empty FEM because I want to use the quad elements. I don't want to do default triangular one, so I use this empty FEM, and we proceed. Okay, if you click on the meshing tab here, notice that we have this surface quad mesh. That's what we want for the whole thing. Okay, in other words, for the original join that I did way up there. Okay, so I click on that and I select the join here. I don't have to worry about this capture business because this is all one piece. There's not going to be any duplicate nodes at the interfaces because I joined them. Okay, and it's parabolic, quadratic, and 100 millimeter. Okay. Remember, this was an issue when I did in tutorial 11 because there were nodes here at the interface which were different. So I had to merge them, but not here because everything was joined at the beginning. It's going to be one big mesh without any duplicate nodes. We say, okay. So you can see that a mesh has been created here, but this is for everything right there for the everything. Now, but these elements will have different sections, okay, different thicknesses. So I go to properties. Here is the shell section. You click on it, and I start picking it from the either from the screen or from those things that I actually joined. So here, like this one, the bottom 2 layer. You click on it. Okay, so the support is a 17 millimeter joint. So here I have to say 17 millimeters. And if it makes me happy, I put a 17 millimeter in front of this too, just so that I know which one is which. Okay, good. So notice that a section has been created right there. Now, I'll do it again. This time for the one that was 16, which was right here. So I put a 16 in front of the name. This is why I was trying to organize these things in a weird way. And of course, the actual thickness is 16 millimeter. Okay. You can see that a 16 millimeter section has been created. Now I do it for 15. And I go to select the one that's for 15 right there. I'll put a 15 in front of that. And put a 15 millimeter as the actual thickness. Good. Another one. Go and select the one that was 14 millimeter. I'll put a 14 in front of this. Please note that you can do these things differently. It's up to you. 14. Okay. Another one for 13, which is this one. I'll put the 13 here. And it's 13 millimeter. And the last one was that fellow, which was 50 millimeter thickness. And the thickness obviously is going to be 50. You say, okay, very good. Let me update these things. Hopefully there are no errors. Yeah, I'm pretty sure it's okay. Good. And by the way, let me quickly save this. And I want to show you something to convince yourself that there are no duplicates enter at the interfaces and things like that. Let me zoom in. So for example, you can see that uh, the nodes are right there. Zoom in further. Okay, this was the this was the 17 millimeter. This was the 15 millimeter. Okay, so if you go to display and click on this numbering visualization, and if you put the cursor there, if you come from below, that node is 95877. If you come from above, that node is also 95877. And this is the interface, okay? You can see that was the interface. Now, when we did this in tutorial 11, the situation was different. I had to make sure that these things were merged together, but not there. Okay, while we are here, let's go and create our coupling. So under connections, there's the coupling. Okay, so let's see now. Coupling, first of all, this is the bottom piece, right here. That's the one of the supports, and the other one are these edges. These edges, for example, this one, that one, turn it around. That fellow and that fellow. So this is the coupling, and it's going to be kinematic coupling. All degrees of freedom are tied, meshed. And if you want, you can call this thing the clamped end, clamped end, clamped end coupling. It's just a name. Now I do another one on this side. Do it again. Another coupling. My point is somewhere, I think there is my point right there. For the other support, select these edges. 1, 2, 3, and 4. Once again, I'm going to make it kinematic, all degrees of freedom, and I'll call this thing loaded end. Loaded end. Loaded end. And then we say OK. Good. I don't think we need anything else. So that's pretty much done here. Okay. Notice that I don't need this long list. Okay. Very good. So now we're going to go to mechanical scenario creation. This is the finite element module. This is, we can do it here, or you can go to the structural scenario creation, but this has more stuff in it. So mechanical scenario creation, click on it. Okay. So we have a structural, and the finite element module, the finite element mesh has been created right there. And then we say, okay. All right. So no procedure. So go to procedures. This is a buckling right here, buckling step right there. Click on it. Notice that the default maximum number of iteration is 30. I'll make this thing 200, maybe unnecessary, but you say okay. All right. Now we go to boundary conditions. The boundary conditions the clamp at the very bottom, right? So let's go and find our, we can do it from the tree, engineering connection, the clamp end right there, this. You select it, and then you say, okay, good. Now the loaded end is on the top, and on purpose, what I'm going to do is I'm going to create them by separate picks. I'll tell you what I mean by that. First of all, let me turn this thing around a little bit. Okay, so what am I talking about? So we go here, we're talking about these loads. First of all, gravity, self-weight. So let's go back here. Under load, there's a gravity. You click on it, and based on the way it was imported, gravity is downward in the y direction. So this is going to be 0, but in the y direction, minus 9.81. Minus 9.81. And then we say, okay, notice that the icon right there, it points in the right direction down below. Okay? All right. Now comes the load. All right. So we go here to load. We were a load under concentrated loads. Let's select the coupling loaded end coupling. In the downward direction, that is your V, which is 4 meganewton. So see that V is downward. So we're going to go in the downward direction, minus, let me just double check on that. 4 meganewton, yeah, minus 4 mega, 1, 2, 3, 4, 5, 6. And we say, okay, it shows it to you. Okay. Then in this direction, another one for the same coupling end. In the direction X, if you go back here, that's the shear one, which is 1.6 meganewton. So it's going to go in the direction X, 1.6 e to the 6. Okay, good, good. All right. And then we say, okay. Then there is a torsion, 22 meganewton meter. So we go here, consider the load in the direction Y of that coupling, in the direction Y, 2 e to the 6. Let's see if it points in the right direction. Yep, it's good. And there's a moment perpendicular to both of these, So another one, same coupling, perpendicular to both of these is in the Z direction. So it's going to be Z is coming toward you, minus, what's the value here? 30 meganewton meter. Yeah. Minus 30. It doesn't look right. We're going to fix it. E to the 6. Yeah, that's good. Okay, let's do a quick save here. And we're going to do a simulation check and then run it. The running may take a few minutes. If it does, then later on when I'll cut it through the video and then tell you how long it took. Okay. So let's go to simulate. First of all, this is a model and scenario check. That's done. This one is simulation check. These are if obvious errors are present, they're going to pop up here. That's fine. Remember, this was load case 2 that we are running, which means that our result should be compared with these buckling factors, 1.4-ish. This is not running it. This is just checking things. And I could have taken more chances, just go ahead directly and run it, but maybe a good idea to do this. I think it's probably done. Not yet. Yeah. Okay. No issues. And now we're going to run it. And I want to keep your eyes on this 1.29. It's 1 p.m., almost 1:30 p.m. And then I'm going to run it. And then if later on, if I cut anything in between, I'm going to come and see how long it took. So let's run it. Okay. This is 1:30. It looks like it's finished, and it took not bad, 3 minutes. Not bad. There's no reason for me to cut any segments of the video. Okay, so let me close this. Okay, this is the deformation mode. So if we go to the displacement, okay, this is the first one, 1.393. So if you go here, yeah, 1.4. That's the first one. The next mode is going to be, well, there are other ones. So probably some of these are the same because it's symmetric. But then there's this one, 1.549 and 1.559. Not bad. Okay, folks. So this is pretty much it. And obviously, you can change the scale here. If you double click on this, you can change the scale if it's too much for you. This one, I don't know, maybe make it 2 if you prefer. Yeah. Good luck.